how we can reverse that to standard form and find the center and radius. Therefore, completing square is very helpful. X squared plus y squared minus 2 hx minus 2 ky plus a squared and plus b squared minus r squared equal to 0. Let's say let d is equals to here minus 2h, let e equals to minus 2k, and let's say let have equals to a squared plus k squared minus r squared. These are all constant, can you see? So as d and e, they are all constant. Our variable is x and y. The rest is just a constant. So having this one, let's rewrite our general equation. So we have x squared plus y squared. Instead of 2h, now we know that it's 2 minus 2h is d. So plus d x. That minus 2h is equals to d. Can you see? Minus 2h is equals to d. Therefore, I'm putting plus here. So dx, alright, plus minus 2k. Minus 2k here it's e. So we have plus e y. And okay, and how? H squared k squared minus r squared, the represent with f. So let's say plus f equals to 0. Okay, with that in mind, we are putting that one to make it clear, so that once when we do squares, completing the square, it's gonna prove that. It's gonna prove that from general we can go back to standard form. Now let's bring the variables that contain x, put x together, variable contain x together, y together, and a constant. Let's bring it to the other side of the equation. So here we have x squared, and we have plus dx, and then we have y squared plus ey, and then have we bring it over, it becomes minus f. For completing square, it states that we have to take out the coefficient of x and y, square it. Once we take the half of the coefficient, we have to square it, and then we have to add to both sides of the equation. This one is x squared, it's not x, is that clear? So completing square states that we have to take half the coefficient of x and y. So here is y squared. Y is here with 1 degree, or power of 1. This one is a degree of 2. Okay, so we have to take half the coefficient of x and y. We square it, and then we add to both sides of the equation. So here, let me read. Okay, same thing. X plus dx plus y squared plus dy equals minus f. Okay, now rearrange them. The coefficient of x is d. The coefficient of y is e. So we have to take the half of this coefficient. Is that clear? And then we'll add to both sides of equation, on the left hand side and on the right hand side as well. So here we have x squared plus dx plus, now we have to take half. So d on 2, that means we divide by 2, taking half, and then we take half, and then we square it, and then we add to both sides of equation. So we add them here. Can you see? So on the other side, I'll have to add this one. Same thing on the other side as well. Is that clear? Okay. Y is it's just the same thing. Like, for instance, let's say I'm having 4 minus 4 is equals to 0. If I bring minus 4 over, it becomes. So on the other end 4, on the other end 4. Can you see? Just the same thing. So like when we have half of d, or d on 2 minus d on 2 is equals to 0. It's 0. But instead of solving it and say 0, we just move it to the other side of the equation. So we have half d, and on the other side we'll have half d. Can you see? So therefore they said add to both sides of the equation. In other words, we didn't change the equation. The equation remains as it is. We just add 0 to it. Is that clear? Are we following?
Yes.
By completing the square, it means that we just add 0 to it. 0 to the equation. But instead of solving it, we do not solve. We expand. Is that clear? Alright. So following that simple algebra method, okay, I'll have to add that one to the other side of the equation, but leave it as it is. So now we are having x term for the x. Okay, let's move on to y. We have y squared plus ey. So now we're going to take half the coefficient of y, add them, square it, and then add them. So plus, we had now, okay, e half and then square. So which equals to, on the left hand side, we have minus f there, minus f on the left hand side. So we bring these two to the left hand side, so we'll have to add them as well. So we have d on 2 squared, then we have d on 2 squared. So this term, it's an expansion form. Once when we factor it will look like something like this: x plus d on 2 all raised to the power of 2. Is that clear? It will look something like this for x term. For y term, it will look something like this: y plus e on 2 equals to all to the square. Alright, it will look something like that. And then on the left hand side we have this one, which is minus f plus, alright, d on 2 square plus e on 2 square. So by seeing that one and relating to standard form, look at it. X minus h squared plus y minus k squared equals to r squared. That's the same format we have in. Can you see? Alright. Y, you would say, how from here we're coming down having this one, factor form. So let's expand that factor form and you'll see. So let's expand. It's like x plus d on 2 squared. It means x plus 2, rather x plus half d times by itself 2 times. Can you see? Squared, it's like times by itself. So if we expand, x multiplied by x is x squared. X multiplied by half d gives us, okay, plus half dx. Can you see? Alright, here half dx multiplied by x, okay, it's half dx, and then half dx multiplied by half dx is, say, d on 2 squared. It's like d times half d times half d, is that clear? So squared. So now look at it. Let's collect like terms now. Half d plus half d is half plus half 1. So we left with dx. So hex squared, we left with dx. On the other end, d on 2. D on 2 all squared. So look at it. The factor form once when we expand, we're coming back to this one. Can you see this square? So now you can see that. So once you complete the square, you factor them. So you bring hex down, plus you bring d half down, and then all inside the bracket raised to the power 2. Is that clear? That's how you factor. The important thing, to complete the square, you have the coefficient of the x and y. You square it and you add to both sides of the equation. That's it. Simple as that. This one. Okay. So now we can see that. Look at it. That will be our h. That will be our k. And this one will be our r. That's it. So here, look at it. We're having it here. So once when we make h become subject, what do? We make h become subject, what do? We divide minus 2 on both sides. So therefore h is equals to h is equals to
b on minus 2.
Okay. Okay. And look at here. When we make k become subject, k equals to okay. And here when we make r become subject, r squared become subject or r become subject, look at it. When we make r become subject, we'll have to bring h squared and k squared to half, or otherwise we bring half here and then we bring r squared over. Can you see? So it will be like when you bring r squared over, it will negative, it will become positive, as positive it is. And then for half, it's positive here. When you bring it over to the right hand side, it becomes negative. So you see that you have h squared plus k squared minus f. And then to make r become subject, we'll have to take square root on both sides. So once when you take square root on both sides, their square root and square cancel, we're left with r. We're left with r, and on the other end, you have this one. So r, to find the radius is h squared plus k squared minus f. Minus f. The general equation, general circle equation, you can reverse the process by applying completing square. Is that clear? X squared plus y squared minus 6x plus 8y equals minus 11 equals to 0. For instance, if you are given an equation, a general equation of circle like this, and then asking us to find center and radius, then you have to go back to completing square. By looking at it, we know that the term here will be equals to d, which h is equals to minus u. Okay. So we know that center h will be minus d on 2, and this one is our d. So we have minus d is minus 6. Okay. So minus minus plus. So positive 6 divided by 2 gives us 3. So our h is 3. Okay, our k minus e on 2. And here our k is positive 8. So we have minus 8 on 2, which is equals to minus 4. So that is our center, which is HK. Alright, we have 3m. Okay, minus 4. Okay, for radius here, we have h squared plus k squared minus f. This one is our half. This one is our half. Look at it. Okay. Here, the expression here is our half. Can you see? This one. Okay. So making R becomes subject. R becomes subject. We have square root. Okay. Our h, we did find h, which is 3 squares. Alright, plus our k, negative 4 square, and then our half minus half, here, our half is minus 11. So we got minus there, can you see? We got minus already in the formula, and then we have minus 11 again. So minus 11, it becomes positive 11. Alright. So 3 squared is 9. 4 squared is 16. So 9 plus 16 is 25. Plus 11? 36. So root of 36 is equals to 6. So look at it. I is wonderful. Look at it. Given any general equation for sample, the coefficient in front of x, okay, it's your d. Is that clear? The coefficient in front of x is your d. The coefficient in front of y is your e, which we calculate, and we have our center, which is 3 and minus 4. Okay, for her, the h and k that you find, the center that you find, h and k, you substitute in, and the constant that in a given general formula, that constant is your half. Is that clear? We do completing square. So for completing square, we know that we have to take half the coefficient of x and y, we square it, and then we add to both sides of the equation. So therefore, x squared minus 2x, the coefficient of x is minus 2. So therefore, we have to, okay, add, and then we have to take half of this one, which is negative 2 on 2, and then we square it. We take half the coefficient of x, we square it, and then we add. So we'll also add on the other side of the equation, don't forget, is that clear? Alright, now let's move on to y. We have y squared minus 4y. Okay, we have to take the half the coefficient now. Okay, plus minus 4 on 2 squared. Are we following? Okay. Now equals to 20. Okay, we're going to plus these two coefficients on the other side as well. So we got minus 2 on 2 squared and minus 4 on 2 squared. So now we can go ahead and simplify. And before we go ahead and simplify this one, once you write them as completing square like this one, you can go ahead and factorize. And to factorize, okay, look at it. We have got the terms that these are for x and these are for y. Alright, look at it. This one, when we factor with okay, look at it, we have x squared, you just write x down here, and then look at the term that you coefficient that you have and you squared it. So look at it. You're gonna, okay. The coefficient is minus 2 on 2. Can you see? Here is x squared, but you just write x. Can you see? And here is minus 2 on 2 squared, but you just write minus 2 on 2. And minus 2 divided by 2 is minus 1. So you just write minus 1. Are we following? Okay. That's for that side of the x. And then plus for y, same thing. For y, same thing. Look at it. Y squared, we just write y. And then here, the coefficient. Minus 4 divided by 2 is minus 2. So you just write this one. Okay, all squared, all squared. And then whole equals to, we have 20 here. Minus 2 divided by 2? Minus 1. Minus 1 squared? 1. Minus 4 divided by 2? Minus 2. Minus 2 squared? 4. Alright. On the other end, you already factor, which is x minus 1 squared. And here we have y minus 2 squared. Okay. 20 plus 1 plus 4? 25. And look what we got. We are in our standard form. Can you see? We are in our standard form now. Standard form of the equation. Alright, look at it. We have x squared, y squared, and equals to 25. So what will be our center? 1. Okay, center is 1. In our standard formula, we know that it's that's the standard form. Minus is in the equation, can you see? So therefore here minus is minus. So that means we have positive 1 and positive 2. If it is plus here, that means okay, the value of the coordinate will be negative value. Is that clear? Alright. Okay, why? You might wonder why from here we go get a vector form. Yes? Okay, look at it. Let's expand one of these two. Still same idea, same concept apply. Look at it. We have x minus 1. Can you see? And squared we have squared. If you expand this one, you will arrive getting this expression. So look at it. Shortcut form, or let me do it. Okay, x minus 1 squared is just like x minus 1 multiplied by x minus 1. So x multiplied by x? X squared. X multiplied by minus 1? Minus x. Minus 1 multiplied by x? Okay, minus 1 multiplied by minus 1? Plus 1. Minus x gives us? Minus 2 x plus 1. This is just the same as this one, look at it. X squared minus 2x minus 2 divided by 2 is? Okay, minus 1 squared is? Positive 1. So we have positive 1. Can you see? Okay, it's just the same as this one. We can expand that one. Okay, now for this case, let's use shortcut form. We normally square the first term, take the square of the first term, last term, and we multiply these two terms and multiply with the power. Yes? So you will see that y squared, and then we have negative 2 squared is? Okay. Negative 2 squared is? Plus 4. Okay, now y multiplied by minus 2? Minus 2y. Minus 2y multiplied by 2? Minus 4. Minus 4y. And here we are at here. Look at it. Minus 4 divided by 2 gives us? Minus 2. Minus 2 squared is? Plus 4. and then we have minus 4y, and then we have y squared. Can you see? So therefore, when you complete the square, when you complete the square by writing this one, like for instance this case, okay, I did not simplify. Can you see? So just leave it as it is. You write as that, and then you leave it as it is. Likewise here, and then from here, how to go into factor. Once you have all these terms written, okay, now you put the brackets, and then the first term squared, can you see? It's x. So you just write x, but without the square sign. Can you see? And then the last term squared, here, look at it. 2 divided by 2 is 1. And then we have negative 1. So I'm writing negative 1 here. I did not square it, I just write negative 1. Can you see? Okay, likewise for y term as well. Y term is a square. So I just write y. I just write y. Okay, for negative 4 divided by 2 is negative 2. So therefore I'm just writing negative 2. Can you see? Negative 2. Without writing the square. So I'm just writing negative 2. And then outside the brackets I'm putting the square. Can you see? So that's how you go about it. Okay, from there you solve the right hand side. So that's how you arrive at standard form equation. And then from standard form equation you can identify your center and your radius. So our radius is 5. Our radius here is 5. Okay. That's applying completing square. Is that clear? That's applying completing.